Okay, so at last the proper teaching session. Okay, artificial intelligence. Applications of artificial intelligence. We have artificial intelligence everywhere now in phones, for example. Yeah, absolutely. Image processing and understanding. Okay, better and better. Natural language processing. You can talk to Siri, Alexa, Google Assistant, whatever. Sorry. No, it's not what you think. I hope so. I haven't been tested, but yeah, I checked my temperature. It's okay. Voice recognition, expert systems, data mining, robotic control, automatic cars. And one interesting thing that happens with AI is that it's less and less noticeable for us. So tasks considered to require AI are more often than not excluded from the definition of AI. One example is OCR, optical character recognition. Now, hardly anyone would say, "Oh, it's an AI. It's just an algorithm." Okay, it's not an AI. It's just character recognition. But it used to be AI, right? So I think that in a couple of years, something like voice recognition will not be considered AI. Perhaps Alexa, when it gives answers in natural language, will still be AI, but I think it will go this way rather. But if something really use logic to think about the reply, the response of the system, it might be AI, but it's something, if it's something low level, we'll just consider this an everyday tool, nothing more. So things that were considered AI are not anymore, and this is called AI effect. AI effect, things just become natural. Definition of artificial intelligence is very tricky. There is no good definition, first of all, mostly because the term itself is very vague, and it depends what you want to include in artificial intelligence. But one possible definition taken from Wikipedia is intelligence demonstrated by machines in contrast to natural intelligence. Can you see any problem with this definition? Intelligence demonstrated by machines, not by natural things like in natural intelligence. My concern with this definition is, okay, but what is intelligence then? Okay, and it's not so easy to answer. Therefore, there's another definition. Artificial intelligence is making computers able to perform the thinking tasks that humans are capable of. Okay, so they think like us. Okay, really like us. I have a 3-minute YouTube video for you. Do you want to continue? Of course I want. I wouldn't click otherwise.
All right, can I start?
No, thanks. I agree.
All right, can I stay in here?
Absolutely, you can sit and watch.
Right.
We'll see what happens.
Come on then, send in your mastermind because it's going to need that.
Alex studies wild birds, which he releases after 3 months of research. This one is nicknamed 007, and it's about to attempt what Alex believes is one of the most complex tests of the animal mind ever constructed. The bird is familiar with the individual objects, but this is the first time he's seen them arranged like this. 8 separate stages that must be completed in a specific order if the puzzle is to be solved. And if the bird succeeds, it'll be a world first. He takes time to have a look and then starts with the short stick. Stage 1. He finds it's too short to reach the food. He then sets off to get the first stone. But he drops it. And another. He seems to be stuck. But then something seems to click. He deploys the first stone. And then another. Got it. The 8th and final stage. Success. 8 individual stages of one complex puzzle completed. That was remarkable. I've never ever seen anything like it. All.
So I will allow myself to change this definition into that one, making computers able to perform the thinking tasks that animals, including humans, are capable of. Okay, we too often forget that intelligence is not just human thing. Actually, I have one more material here. There is a nice video in it as well. I will not present it now, but you can do it later from home. It's about very primitive organisms that are called slime mold that are used right here to propose a map of Tokyo railway system. They have no brain, but they are capable to create a map. And you know what? When they created this map, you may learn from this video how it is done. This map is indeed very similar to what in real life was created for Tokyo. So you really don't need a very complicated, highly organized mind, which I don't say that birds don't have, crows particularly, okay? But it can be done in many different aspects, and we will be looking into some smart algorithms that don't try to mimic the construction of human brain, but try to mimic the way in which we behave or think and then behave, or sometimes first behave then think. Also superhuman abilities, why not? Academic AI in which many people, including myself, are involved in this building. They are about something slightly different. It all started quite a long time ago, 70 years ago actually, in 1950 with Alan Turing's paper entitled Computing Machinery and Intelligence, published in 1950. The main question was, can machines think? And in this paper, he proposed this famous test, okay, Turing test. The machine is said to have passed the test when a human judge cannot reliably tell the machine from the human. So configuration is something like that. You have a machine, you have another person, a human, So two test objects, you are separated by a wall from them, and you only have text communication. They use teletext at that times. And here is a person leading the test, and when this person, after a number of questions, cannot recognize which of them is a machine and which of them is human, the test is passed. Okay, this is an interesting concept, not of very good use right now in AI science, because it's generally considered to be terribly outdated. Okay, so we have areas of very advanced AI which wouldn't be appropriate to be tested with this kind of a test. This is a test for very small section of AI, communicating machines, communicating bots. Okay, so if you have a communicating bot and you cannot recognize him from a human, that's it. In many aspects, we have solutions who won the test, who passed the test, but none of these solutions really passed this test in terms of general and completely unrestrained, unconstrained test. All right, but this doesn't mean that we have not working AI. This means that we not necessarily have communicating bots. Anyway, as an academic domain, AI is funded since 1956. So look, it's wow, 64 years. Okay, it's much longer than even I am alive, and I'm old, of course. My kids tell me I'm old, so I am. We had several ways of optimism that, oh, AI, in a few years, AI will be better than people. And then we had something that was called AI winter, when this expected progress in AI research didn't actually happen. And these were periods of disappointment for quite a long time, all right? So the development of AI research was like in jumps, several jumps, with long breaks in between. Current wave is powered by statistical methods, very powerful methods, and everything is working on it. Basically, it is all about neural networks and a technique that is known as deep learning. So this is what is currently done in the area of academic AI. Reasoning, planning, learning, machine learning, knowledge representation, perception, and world models as all the stuff that academic AI is currently working on. But even in the area of academic AI, we can talk about two flavors of AI. One is called strong, one is called weak AI. What is strong AI? Strong AI are systems that mimic human thought process. So scientists imagine that our thought process might be based on something like this, and it isn't even called neural networks. Okay, in fact, this is just a mathematical function which can be visualized with a nice graph like this. But in fact, this is just maths, a set of mathematical formulas, okay, that can solve problems. Okay, but there is also weak AI, and weak AI is just looking how we can find an algorithm that can solve some kind of a real-world problem. And technically speaking, game AI is the area of weak AI, because we don't need, first of all, to mimic the human brain structure in a game. What we need is something that is lifelike, believable, natural, and perhaps most importantly of all these, entertaining. Okay, so the goal here is to make you believe you play against something that is intelligent. Okay, you will never believe that you are playing against a small human hidden inside your computer. Okay, but you can have a feeling that something inside is really intelligent. So these are the four main goals ahead of gaming AI. And one absolutely fantastic thing is that sometimes simple things look good. I have one more YouTube video for you. Okay, this game is Pac-Man is quite old, and it had no AI in the way in which we understand AI now. It's fully based on simple algorithms. But one of the early reviews of the game was like this. To give the game some tension, some clever AI was programmed into the game. The ghosts would group up, attack the players, and disperse. Each ghost had its own AI. The four of them are programmed to set a trap, with Blinky leading the player into ambush, where the other three lie in wait. WTF? So what's the terrible failure in it? Okay, this is an example of a simple algorithm with no modern AI technique in it, with ghosts just walking around. But you know what was the trick? Each of the four ghosts in Pac-Man has a slightly different program behind it. It's a slightly different algorithm of behavior. They move with a slightly different speed, and when they arrive to a crossing, they have four different algorithms to make decisions about where to turn and how to interact with the player. And this created the only AI thing in it was that when they made a decision whether to turn left or turn right, in some circumstances, and again, these circumstances were different for each ghost, in some circumstances, they took into consideration the position, geometrical position, so X, Y coordinates of the player. And sometimes they would just turn to the same into the same direction. With some ghosts preferring turning left, right, some preferring going up and down. Okay, but just differentiating the four algorithms between the four ghosts created an effect which perhaps is not very impressive for us today playing Pac-Man. However, this game is still powerful, and I still know many people enjoying playing Pac-Man. But in those times, people were absolutely sure that there is some absolutely powerful magic in it. AI, yeah. Pac-Man AI. There was no such thing, but people were absolutely excited and absolutely sure that there was. So the conclusion for this is sometimes you don't have to put anything really complex to get an amazing AI effect. When complex things look bad, most of the complex things I've seen, this is a citation from my favorite AI book. Most of the complex things I've seen that looked bad never made it to the final game. It's a perennial temptation for developers to use the latest techniques and the most hyped algorithms to implement their character AI. Late in the development, when the learning AI still can't learn how to steer a car around the track without driving off at every corner, the simpler algorithms invariably come to the rescue and make it into the game's release. And this is a repeating pattern, that actually gaming industry uses a limited number of reasonably simple AI techniques and experiments with something very advanced, with people specifically coming from academia, with academic AI, trying to discover something incredible for gaming. It was mostly failure. So AI in games is first of all illusion. Illusion of intelligence may be achieved in various ways, not necessarily using real AI, but for example by using visual cues and simple but lifelike behavior. I will give you an example. It wasn't a game. I was hired to a industrial project that was done in collaboration between Kingston University and one of the, actually this was a lift industry consultancy company. So a company who helped construction companies to build lifts or elevators, okay? We did a modeling tool with experts in digital simulation, a modeling tool how a lift would behave in a high-rise building with many people traveling between floors, mostly going to offices, places like that, okay? And I was responsible for visualization. So I created a 3D scene with a number of people waiting for a lift. And one day, I remember it was late in the night, I just thought, oh, I will add something to make it a little bit funnier so that, you know, it was a industrial simulation, so I had characters just standing like this. And I added additional behavior after, I think it was after 20 seconds of waiting. They did something like this. Very mechanical because I didn't have a really good animation engine. And 10 seconds later, they made a gesture like this. And I had a demo the very next day with very important people from lift industry. We ran this presentation, and you know what was the reaction? Wow, these passengers are intelligent. They really are waiting there. How you did this thing? How it is possible that they check the time after some? It was trivial. There was no AI at all. It was just a timer, a random timer. So the first event was 20 seconds from the waiting initiation moment plus, so T plus 20 plus, I think 5 times random, so something like that. And then 30 plus 10 times random was the timing, a simple animation, very primitive thing. Well, these were not gamers. Perhaps gamers would have a better understanding that what they were looking at was really, really a trivial thing. But they were absolutely amazed. And I was really amazed that they were amazed. This was what was awesome for me. Okay, so using visual cues and simple but lifelike behaviors. So if you startle an agent, it should act alerted or startled, basically. Agent hears something suspicious, then it could stop, look around, say, is anyone there? Something like that. Another very important thing, intelligent agents shouldn't be caught on stupid things. So, for example, frequently change strategies and phrases, all right? Okay, Google, what's the meaning of life?
Matter, including the capacity for growth, reproduction, functional activity,
Okay, if
and
it's
continual change preceding death.
Wikipedia about
Also,
life.
42.
Also 42, yes. Okay, Google, what's the meaning of life?
I have a factory warranty, so I don't worry about things like that.
Okay, Google, what's the meaning of life?
To exist means to have a way of living. My way of living is to search, so I guess the
Okay,
meaning of
anyway,
life is...
what I wanted to show is that stupid Google, sorry, not so stupid, it's quite smart. Google Assistant, the same question asked 3 times, and 3 times it will use a different strategy to answer, okay? The same thing will be if you use Siri, if you use Alexa, whatever, okay? Because people who created these systems know that AI shouldn't be caught on using the same strategy every time, because this is not what people do. Don't do impossible, don't cheat, don't know everything, don't know if you are an intelligent agent in the game, don't know things that you shouldn't know, don't know what's on the other side of the wall if you can't see through the wall. take care about the perception window. So do the things in at the time you should do it, all right? Priority is on being efficient, not necessarily very clever, okay? All right, so awareness of an agent. If you have a player here in a room and there is an enemy outside, then this enemy has the visual awareness, which is shown like this, okay? This enemy can know about stuff, but he cannot know about what's inside the room. This is what we call visual awareness. So the enemy cannot see us, so it won't come into and kill us, all right? But the enemy can have audio awareness, okay? And if we do something, some kind of a noise, it will know and it will enter. But look how many interesting scenarios this absolutely trivial scheme creates. Okay, as a player, you know that you can hide in the room and you will be invisible, but you also cannot do anything that will create a noise because then we will be spotted, all right? A real life situation and a very simple in-game solution. Here are some examples from Metal Gear Solid game and some diagrams showing what the players are NPCs, all right, non-player character. I'm sure you know this acronym. What they can see, how they can behave. In gaming, we will quite often use something that is called illusion of intelligence. So we will be using many aspects of hacks. Heuristics. Heuristic is an educated guess, algorithmic educated guess. So we just guess something. We are not entirely sure. We guess something. If we have reason for such a guess, then why not to use it? Because it will be faster than calculating everything. And of course, we will be using algorithms. And the next 5 weeks, we'll be concentrating on looking into various types of AI algorithms. Starting next week, we'll concentrate on state machines and decision trees, autonomous agents, pathfinding, perhaps a little bit of machine learning. And the final thing I wanted to show you today, model of AI. Sorry. My cough is because I'm talking too long, and actually I have to emit my voice through this mask, so I have to speak louder than normally, and this leaves an effect on my throat. So this generates cough. It's not coronavirus. So the central thing for our model of AI is decision making, and this decision making may be very complex, based on brains using deep learning approach to neural networks, whatever you want, or maybe very simple, like decision tree, okay, which we will learn very, very soon. This decision making will translate directly into movement of the game character. And these two blocks together, decision making and movement, create character AI. All right? So if we think about things like decision tree, this mostly about we're thinking about algorithms like pathfinding. This is mostly about movement. Now, this can be controlled by a high-level strategy, and we will be including a little bit less of strategy. So we will be mostly concentrating on character AI in this part of the module. Also, what we have here is world interface. So there will be no AI without some kind of interaction with the environment, with the world. And this is very important. We also have animation and physics, which are tools used by character AI to express itself. So to turn from a decision about movement into the actual movement. So it needs physics to interact with the world. It needs animating just to show you that it is moving. And we have also other aspects here, like content creation, a very advanced aspect, And scripting, we'll be looking a little bit into scripted AI as well. Scripting is basically cheating, okay, because it's writing programs about how the character should behave. But if this scripting is based on decision trees, okay, this becomes a real AI. So this is more or less the area in which we will be moving across the next 5 weeks. So, guys, we arrived to the end of the first session this year. It's 1:45 now, so you have a little bit more time for your lunch break. Thank you very much. The next session is online, so I will see you in person next time in 2 weeks' time only.